So let's move forward to our next problem. So our next problem is task scheduler. It is a very interesting problem. Okay, task scheduler. This problem can be done in a lot of ways. Okay, so whenever in any problem of priority queue, this problem can be done in using sorting also. Okay, the purpose of not using sorting is because of that log part. Okay, so many times that log part will be beneficial for us. Okay, sorting in many problems, sorting problem will be very easy. If you can use priority queue, there's a huge chance that you can use sorting as well, but sorting will take much time than priority queue. Okay, so that's why we move to priority queue. Okay, so let's discuss this problem also. So please pause this lecture and read this problem statement. Okay, and after this I'll explain you. So let me explain you this. We have given a array task. Okay, we have given a task array, and n is nothing but the CPU cycle. N is nothing but the CPU cycle. Okay, so we have given n and we have given task, and in this task array we have given some uppercase letters from A to Z, A to Z. Okay, now in this task array, whatever task is there, A, B, C, D till Z, and we have given this, and that is cooldown period. So what we need to do in this task, we have A, okay, A, then B, 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 and n is given as 2. That means that if I'm using a particular character, if I'm using the particular character, I cannot use this is the cooldown period, so I cannot use till the next 2 cycles. What does it means? So if I'm using this, let's say I'm using this A. Okay, now for next 2 cycles, I cannot use A. So after 2 cycles, I can use A. Okay, then after 2 cycles, I can use A like this. Okay, similarly, if I use B, I cannot use B here. Okay, so I can use B only after this cooldown period. So after 2 CPU cycles, I can use this. Okay, so B will be here. After 2 cycles, I can use this, so B will be here. Okay, similarly, let's say we have C also, so we can use C also like this. Okay, now if you take this example only, if you take this example only, then what will happen? Okay, so this is our example. We have 3A and 3Bs. Okay, and this is the cooldown period. So we need to return the number of CPU cycles required. Number of CPU cycle requires to complete these tasks. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are nothing but CPU cycles. In each CPU cycle, we can perform only one task. So what is the problem statement? We have given a task array and we have given a cooldown period, and at each CPU cycle we can perform only one task. Okay, so either we'll perform one task or this can be idle. Okay, this can be idle, but we cannot perform any task between this cooldown period. Okay, so this is given that there must be at least an unit of time between any two types. Okay, we usually called as cooldown period. Okay, cooldown period. So there can be multiple ways. Okay, there can be multiple ways to do this problem. But the thing is, we need to return the least number of time. Least number of time. Okay, so what we can do this like A, then A, then A, then B, then B, then B, like this also. Okay, but these idle CPU cycles, we need to reduce them. Okay, what if let's say we have given example, let's say A, and then B, B. Okay, what we if we start we doing B, what if we start doing B? So what will happen? B, then let's say cooldown period is 2. So we will have a cooldown period of 2 CPU cycles. Then we will again use B. Okay, then we have cooldown period of these 2 cycles. And if we put A here, if we put A here, okay, then after 2 cycles, so we cannot use this cycle and this cycle as well. So we will put A here, okay, like this. So how many cycles required to full complete this? 1, 2, 3, 4, 5, 6, 7, 8. Okay. And if we start from A, what will happen? We'll put A here, then A here, then A here. Okay. And we'll put B here, B here. So how many cycles required? 1, 2, 3, 4, 5, 6, 7. Okay. So if you start from B, it will take minimum of 8 cycle. If you start from A, it will take minimum of 7 cycle. Okay. And you cannot eliminate this idle time. Why? Because neither you can use A or B to perform because of the cooldown period of 2. Okay. So every task will have the cooldown period of 2 here if n is equals to 2. Okay. So if you carefully see this example, what is happening? A, we need to perform A 3 times. Okay, we need to do A task 3 times. And we need to do B task 2 times. Okay, we need to do B task 2 times. So whichever maximum, okay, whichever maximum task is there, if we keep starting in that way, let's say we have A, B, C, D, E, F like this. We have to do A task 10 times, B task 9 times, C task 8 times, D task 7 times, E task 6 times, F task 5 times. If we start doing our task in that order, that means maximum count order. Okay, maximum count of the task order. If we start doing our task in that order, then we can do that task in minimum time. That task in minimum time. Okay, do a dry run of taking a lot of examples. You will observe this. Okay, after doing a lot of dry runs, I can observe this. Okay, so what is why this is working? Because we have a cooldown period of n, right? That is for all the tasks, right? That is for all the tasks. So it is similar to putting big and small balls in a jar. Okay, so what is happening? If you keep putting small jars, then there will be no place to put the big one. Okay, so what we need to do, we need to first put the big balls in our jar. Okay, then the space left in between, we can put small balls as well. So that will be the better idea. Okay, that's what we are doing in this. So how we can do this? In between this bigger task, okay, whatever the maximum task, if we keep doing this regularly, and in between if we perform different tasks, then we will surely get the task done in minimum time. Okay, so this is our intuition. So how we can do this? We can have multiple approaches. Okay, first we can have sorting. Okay, so what you can do, you can store the count of each task, let's say A, B, C, D like this. Okay, and let's say this is 10, 20, 30. Okay, 5, 6. These are the basically number of times particular task is performed. Number of times particular task is performed. Okay, so if you sort this in form of maximum times the task is performed. Okay, if you sort in that way, then what you can do, you can first use this, then this, then this, then this, then this. Okay, so sorting, just try to perform this. Okay, there will be some mathematical operation you need to do, but try to perform this sorting. Now, why I picked this problem? Because of this one, because of priority queue. Okay, it can be done in using priority queue or without using priority queue as well, but let's solve it using priority queue. So first we will see using priority queue, and then we will see using without priority queue. Okay, the sorting approach, just try to do this. Okay, so if you understand this second and third approach, you will most probably do this in sorting as well. Okay, so what is our task? We have given task array. Okay, and a cooldown period. Correct. So if we have given a task array like A, B, B, C, C, like this, and we have a cooldown period of 2, then let's take the cycle. Okay, what can be one cycle? What can be one cycle? If I take A here, okay, and N is 2, consider this as one cycle. Okay, consider this as one cycle. Because what we will do, we'll keep breaking the problem, we'll keep breaking the task. Okay, and we will keep performing the alternate task. So what I will do, let's take this as cycle. So if I take A, okay, because A is the maximum count. Okay, A has maximum count. So if I take A here, okay, I cannot take A here and here as well. Okay, so consider this as one cycle. Okay, consider this as one cycle. This will be nothing but n plus 1 CPU cycles. Okay, n plus 1 CPU cycles. So in each cycle, this is the n plus 1 time cycle. Okay, if I take A here, I cannot take A to the these two positions. So I will fill these two positions with other tasks. I will fill these two positions with other tasks. So what I will do, I'll put the next largest one. Let's say B here. Okay. Then I will put the next largest one. Let's put C here. Okay. Now this will be one cycle completed. A, B, C. Okay. Now what I will do, I'll take another cycle. I'll take another cycle of n plus 1 time, right? Because in n plus 1 time only I can complete this. So that will be our, it's a group. Okay, if name it as group only. Okay, it's a group of n plus 1 cycles. Okay, so what I will do, ABC. Okay, then ABC, then only A is there. So we have one group, we have one group, we have one group. Okay, so group in the last group, it may happen that it will not run for all the n plus 1 cycles. Okay, so for this we will take a edge case. Okay, we'll take another case, but before that, all group will have n plus 1 cycles. Okay, so this will have n plus 1 cycle, this will have n plus 1 cycle, and so on, except the last one. Okay, so what is my approach? What I will do, I will take a priority queue. Okay, and I will take unordered map, or we can say hash table. Okay, because what we are doing, we are using uppercase letters. Okay, so what you can do, you can take a hash table of size 26. Okay, size 26. Okay, for storing A to Z, or you can take another map that we know how to take it, right? So what is my approach? What I will do, I will first put all the counts in hash table. Okay, let me take this hash table. Okay, let's take example. We have triple A, double B, double C, right? So this hash table will store at index 0, it will store what? It will store this count 3. At index 1, it is store count 2. At index 2, it is store count 3. Okay, these are nothing but indexes. If you are taking hash table, this is indexing, this is count. Okay, inside value. If you are using map, then it will be A, it will be B, it will be C, like this. Okay, and this will be nothing but 2 only. Okay, so if you are taking hash table, let's take a hash table. Okay, so in hash table, we'll have a 26 size hash table, 0 till 25. Okay, and it will store of count A, it will store the count of B, it will store the count of C. We will have 3 here, 2 here, 2 here. Okay, this is a hash table. Okay, we will take a hash table to store all the counts. Why we are storing it? To get the maximum count. Okay, so we are storing this to use the maximum count, to know that whichever is maximum, we will use them first. Okay, and what I will do, I will put them in priority queue. Okay, if I push all the elements in priority queue, what will happen? Let's say this is our priority queue. Okay, this is our priority queue, that is nothing but our max heap. Okay, so it will store tasks like 3, 2, 2, right? What I will do, first I will take a hash table. put all the count of each task in hash table, and then I will put all the values in priority queue. Okay, so now my priority queue stores the count. Okay, and why I have using this priority queue? Because the root will always have the maximum. Okay, so we will always use the maximum task first. Okay, we have a b b c c. We have this priority queue, which is it stores 3 2 2. Okay, and we are using hash table just for one time. Okay, for the storing the count only, for one time only. Okay, it contains 3 2 2. So we have hash table, we are using it once only. We have priority queue, we have all the counts in priority queue. Okay, we don't need to write a b c inside the priority queue. Why? Because we just want the cycle count. Okay, so we don't bother about what is a, what is b, what is c. Okay, we can take it as in the form of count only. So now please take care what I will do. So I will run for each group. Okay, so how many group? So we have the cooldown period of n, right? So for n time I cannot use this, right? So for n time I cannot use this, so I will run a for loop. Okay, I will run a for loop from 0 till less than n plus 1. Okay, n plus 1 times. Okay, because the cool, if I am using this a here, I cannot use this for next n time. So this is a group of n plus 1. Okay, so I will run this loop for n plus 1 times. Okay, now what I will do, inside this I will check if my priority queue is not empty. If my priority queue is not empty, then what I will do, I will take this, I will pop this out. Okay, so I will pop this out. I will pop this out. Okay, I will pop this out. So let's take it in the max element. Let's take it in the max element. Okay, so it will store the top element, and I will pop this out. I will pop this out. Okay, so we had three tasks. Okay, so I want to perform one task now and two tasks later. Okay, so I will take a temp vector to store the remaining task. Okay, so I will store the remaining task here. Okay, I will put the condition. Okay, so if my maximum element is greater than 1, that is, if it is greater than 1, if it is 1, then we can perform this task here only. Okay, if it is greater than 1, then I will store it in the temp. Okay, so I will store max minus 1 in the temp. Okay, so I will store the remaining task in the temp so that we can perform this task later. Okay, and I will increment my time. So initially I will take time as 0. Okay, this we will do using inside the while loop while my priority queue is not empty. Okay, so until my priority queue have elements, we will run this. So at every cycle, what I will do, I will perform one task. Okay, and put other task in temp. So I will keep doing this. Okay, I will pop this out. Okay, so I have popped this out and stored it in the temp. Now again, next time what I will do, I'll pop this out. I'll pop this out, and now my remaining task will be 1. Okay, my time will be increased, so my time will be 2 here. Now run this. Next time I'll pop this out. I'll pop this out from priority queue. Okay, so two tasks were there, one I will perform and one I will put in the remaining task. Okay, so now my priority queue is empty. Okay, after this loop what I will do, I still have 2 1 1 tasks remaining. So I'll again put it in the priority queue, so it will be 2 1 1. Okay, so this temp array I will take inside this. Okay, so one time I have done, what will happen, again this will run. Okay, so what I will do, again we have 2 1 1. So again I will run this. Again I will done one task here and put one task in the temp. Okay, so again I have to perform one task at later. Now pop this out. Okay, run this for loop. We have one task here. Okay, one task we will perform here itself. Okay, I will increase my time. Now we have one task here. Okay, so I can perform this here only. So we will increase my time. Okay, after this, after this, we have one task remaining in the temp array. Okay, so I will push this back in the priority queue. Now I have one task. Okay, now we have performed ABC, ABC, right? So for first cycle, for first group, we have performed this ABC. In second group, we have performed ABC. Okay, in first time we have performed, see this, in first group we have performed ABC, and then again we are pushing back elements in the priority queue, and again we are running this. Okay, so we have pushed ABC, we have pushed ABC. Okay, now I am remaining with A only. Okay, I am remaining with A only. So how to handle this A? So for first two groups, ABC and ABC, we have performed this two times. Now we need to perform this for only A. Okay, we have one here in priority queue. Okay, so after this for loop, what we will do, we will copy this. Okay, so we'll copy, I'm writing here, copy element from my temp to priority queue. Okay, I will copy these elements. Now after this, I will check if my priority queue, if my priority queue is empty, if my priority queue is empty. Okay, then what I will do, i will add I will add my current time in my result. I will take a result variable outside. Okay, and every time if my priority queue is empty, then I will increment result with time. If it is not empty, then what I will do, I will put n plus 1. Okay, I will increment it by n plus 1 times. So for first two groups, okay, for first two groups, for ABC and ABC group, what I will do, I will increment n plus 1 in result. Okay, n plus 1. So for first case, it was 2 1 1. Okay, and for second case, it was 1. And in third case for A only, what will happen? It will get empty inside this. Okay, so for this case, I will add n plus 1. For this case also, I will add n plus 1 because it is not empty. Okay, we have remaining elements, and for this case it is empty. So what I will do, I will add the time of this A only. Okay, I will add this time of this only. Okay, so let's code it and then you will understand it properly. Okay, so this is our solution for our current problem using priority queue. Okay, what we are doing, we are taking a hash table to store the count of each task. Let's say if A have 3 tasks, B have 2 tasks, like this. Okay, and what we will do, we will update this in priority queue. Okay, so priority queue will store. So let's take example A, B, B, C, C. Okay, so priority queue will store the count of each task. Okay, so it will store like 3, then 2, then 2. Okay, and now we are taking the result. Okay, so it will, what it will do, it will add all the time cycles. So till here what we are doing, we are just putting the count of each task in priority queue. Okay, now come to this is the important one. So we are running a loop until my priority queue get empty. Okay, until I can execute all the tasks. So we are taking this as cycle. Okay, so every time we are grouping it in a cycle of n plus 1. Why? So that I can do this like A, B, C, then A, B, C, like this. So this will be nothing but our one cycle. A, B, C is our one cycle of n plus 1. Okay, because I can perform the task only after my cooldown period. Okay, I can perform the particular task only after cooldown period. So this will make sure that I will perform the task only after cooldown period. So what will happen? We have 3, 2, 2 in our priority queue. Okay, and we will execute this. Okay, so we'll pop this out. Okay, so we will pop 3. Okay, we will pop 3 and we will execute one task. So increment our time. So our time will be 1. Okay, now see A, the count of A is 3. Okay, and we are executing only 1. We can execute only one task at a time. So remaining we have to store it somewhere. So I'm taking remaining array to store the count. Okay, So remaining array will now store my remaining task. Okay, so it remaining array will store 2 now. Okay, again I will run this. So now my priority queue will have 2 at the top. Okay, so I'll pop 2. Okay, and I will store remaining one in the remaining array. So I will store 1 here. Okay, so remaining shows that we have remaining 2 tasks of A and 1 task of B. Okay, now I have popped this out. So I will again go through this. Okay, so my priority queue top has 2. Okay, so pop it out. Okay, pop 2. So my priority queue will be empty now. Okay, and it had 2. So what I will do, I will store the remaining. So remaining we have 1 task. Okay, so till now we have performed 1 cycle. Okay, so we had triple A, double B, double C, but we have performed 1A, 1B, 1C. Okay, this is nothing but 1 cycle. So after that we will remaining will be A, B, C. Okay, so we have 2 occurrence of A, 1 occurrence of B, and 1 occurrence of C remaining. Okay, now after this my priority queue is empty in this case. Okay, so what I will do, I will again push all the counts. I will again push this remaining in the priority queue. So now in this step what I'm doing, I'm just pushing this back in the priority queue. Okay, so my priority queue will store now 2 1 1. Okay, and after this step what I will do, if my priority queue is empty, my priority queue is not empty. Okay, so I will add this cycle time. Okay, so I will add this cycle time in result. Okay, so my result will store the cycle time. Cycle time is nothing but n plus 1, that is 3. Okay, now I trade this. Okay, so pop 2. So this remaining will be nothing. Okay, we have 2 on 1 priority queue. So again run this, we'll pop 2. Okay, remaining will be 1. Okay, then we will pop 1, remaining will be 0. Okay, we'll not push it in remaining. Then again pop 1. Okay, so it will be empty. It will be empty, and in remaining we have 1. Okay, again if you run this, we will push back, in the priority queue. Okay, so push 1 in the priority queue. Priority queue will have 1 here. Okay, and priority queue is empty, no, so add. So it is checking that we are using whole cycle or not. Okay, so in the last what will happen, that it will not execute the whole cycle. Okay, but till now we have executed the whole cycle of ABC again. Okay, so what happened till now, we have used ABC, then we have used ABC. Okay, so my result will store ABC 2 times. Okay, now my result will have nothing but 6. Okay, now we will again have 1 in priority queue, so pop this 1. Okay, remaining will be nothing. So now my priority queue will be empty. Okay, so that means that we have executed only 1 task. So what I will do here, my priority queue is empty. That means whatever task we have executed in the last cycle, just add that only. Okay, so we had only 1 task in the last, so we'll add 1 only. Okay, we'll add 1 only. So it will be nothing but 3 plus 3 plus 1, that will be 7. Okay, so if you see, it will take like this only, 3, then 3, then 1. Okay, so what we are doing, we are performing this in group like this. Okay, in first group ABC will execute, in second group ABC will execute, in third group only A will execute. Okay, and what we are doing, after performing this group, we are storing the remaining count in this remaining array. Okay, so that's how we are doing this. Okay, that's how we are doing this. Okay, so if I run this code, what's the issue? Okay, let's comment this out. Okay, let's run this. Yeah, let's run the examples. Yeah, let's submit this. Okay, it is accepted. It is accepted. Okay, So I hope you understood this problem. Okay, what we are doing basically, we are pushing the count in the priority queue first, and then we are taking a remaining vector so that we can perform the rest operations. Okay, we can perform the rest task, and we are this loop. This will make sure that we are executing every task in this cycle. Okay, we are executing every task in that particular cycle. So if we have A, B, C, then we're executing A, then B, then C. Okay. Let's say we have D, E, F like this also. Okay. And we have N equals to 2 also. Then we can perform use according to priority queue only. Okay. So priority queue will take care of this. We just need to again push back the remaining task in priority queue. Okay. And priority queue will manage based on the maxi property. So basically we need to take care of the remaining task. Okay, if we are performing current task, just make sure that we will again push the remaining count of that particular task in the priority queue. Okay, now how much time it will take? How much time it will take? So basically we are pushing and popping. We have, let's say, m tasks. Okay, we have n tasks. So we are pushing and popping m task only. Okay, so in heap, in heap or in priority queue, how much time it will take? It will take order of how many tasks, log how many elements are there in priority queue. So we are using uppercase letters. Okay, so at max we can have only 26 elements in our priority queue. Okay, this will be our time. Okay, this will be for insertion and same will be for deletion. So it will be nothing but 2. Okay, 2 times m log 26. Okay, and m log 26 is nothing but constant only, so you can remove this as well. So it will be order of m only. Okay, where m is the number of tasks. I am not taking n because n is already there in the problem, so it will get confused. Okay, and what will the space complexity? We are using space for priority queue. So my priority queue will take at max order of 26, and we are taking a hash table. It will also take how much time? How much space? Order of 26. Okay, this is also constant. This is also constant. Okay, so the time complexity is nothing but order of m. Space complexity you can mention order of 26, order of 26. So remaining will store how much? Remaining will also take what? Order of 26 only, right? Remaining will order take order of 26 because we have 26 distinct characters only, right? So space you can mention that order of 26 only. Okay, and time complexity is order of m, where m is the number of tasks. Okay, now the second approach is using map only. Okay, so let's discuss that also. Okay, so this is the another approach. What we can do, we can take similar to previously unordered map or hash table for storing frequency. Okay, here what we are using this max frequency. Okay, and based on this only we can get our answer. Okay, so let's say we have a 4 A's, 3 B's, 3 C's. Okay, so what is the maximum frequency of particular task? We have 4. A frequencies 4, B have 3, C have 3. Okay, so we will store the frequency, we'll update the frequency array as well as the maximum frequency. Okay, now I'll go through this frequency array. Okay, so let's say n equals to 2. Okay, cooldown period is 2. So how it will execute? It will execute like ABC. Okay, then ABC, then ABC. Okay, and at the end A will left alone. Okay, so for these one, it is simple calculation. It is simple calculation. Okay, it is simple calculation like this: maximum frequency minus 1 into n plus 1. Okay, n plus 1 is nothing but this cycle: 1, 2, 3. Okay, so we have 4 A's. We have 4 A's. So for 3 A's, we can do simple calculation like this. Okay, it will be maximum frequency minus 1, or means 3 for 3 A's into my n plus 1. So it will be 3, 3, 3, 9. Okay, but for last one we can have A also, we can have AB also, we can have ABC also. Okay, so this can be of any size. So what I will do, I will update my group size. Okay, so at the end I will update my group size for all the maximum frequency elements. Okay, so at the end we have a remaining, so it will be 1. Okay, so I will update this, it will be 1 only. Let's say we have 4 b's, so it will be a and b. Okay, 4 a's and 4 b's. So I will update group size. Okay, so group size will be, at the end group size will be 2. Okay, so group size is nothing but the end, it is storing nothing but the end group size. Okay, because for previous one it will be simple as this one. Okay, so that's how you can solve this problem. Okay, for previous one we'll get the all the groups, and for the last one we'll calculate the group size like this, and we will add these. Okay, so we will add this group size separately, and for the previous ones we can execute this. Okay, just take some examples and do try runs. Okay, it is just how we are doing it in round robin order. Okay, so this is pattern similar to round robin pattern. Okay, if you have studied process scheduling in OS, then you can get it. Okay, in round robin also we do same things only. Okay, so this is all about this problem. Let me submit this. Yeah, it is working fine. Okay, let me submit this. It is accepted. Yeah. So this is all about this problem, and it is also taking how much time? It is taking order of m time, where m is the length of task, and this is nothing but order of 26. Okay, frequency array size will be 26 only. Okay, and this is just order of one operations. So space will be order of 26, size will be order of m plus order of 26. So both approaches are taking almost similar time. Okay, I wanted to teach you both. So this is all about this problem. Let's move forward to next problem.